Welcome to this session. The title here, The Rise of Internal Fork. It could almost be a working title for next Star Wars movie or something like that. So let's try to make it exciting. I understand that I might be the only thing that's between you and final keynotes and a well-deserved drink, so I will try to handle the situation nevertheless. So I'm Daniel. I'm CTO at FossID. The name FossID, it's a combination of Foss, as in free open source software, and ID, as in the ability to identify free and open source software. We're a company in the what you call software composition analysis domain. We produce tools and to some degree services that allow our customers to use and manage open source in a responsible way, both when it comes to honoring licenses and tackle security issues. We are a fairly new member of FINOS. In the morning presentation here you saw we were part of the slide with new people added to the organization, so we are very excited to be part here for the first time for us, and we will look into how we can both open source more of our solutions and how we can address some of the use cases that are relevant here, not the least for the financial industry. But today I'm here to talk about what we call internal forks. And just to set the context a little bit, and I mean this is not news to anyone, but I just want to emphasize that the way software is being developed has changed rapidly. I began my career in the software industry for some 25 years ago, and at that point in time, I mean, to a large degree, you are writing software yourself. This was a little bit before sort of Linux and open source tsunami and so on. That was perhaps the first change, that all of a sudden you were not writing all the software yourself, you were relying on a lot of components and libraries that people have helped you write. And what we see now with AI and so on, perhaps that's just the second big change. But nevertheless, the end result is that as of today, the vast majority, probably more than 90% of the code that you have in your total application is not code that you or your team has written yourself. It is code that has, to a large degree, comes from the open source community and is in some cases being nowadays AI generated. And we see that as part of our business, we do software audits, and we see that open source is showing up in every audit that we do. There's not a single project that can claim that, yeah, we're not using any open source, because in reality, they do. And one of the things that causes a bit of concern is the very topic of internal forks, and that is what we're here for today. So let's start with a little bit of definitions. What is a fork? Well, most of you probably know a fork is basically my own local and potentially modified branch of a piece of software. And when I say internal fork, I usually mean here a fork that I never intended to upstream or contribute back. That is something that I've kept for myself internally. Forks in itself are not a bad thing. I mean, that's basically part of everyday development flow. But internal forks in particular do bring some consequences. And we can discuss what these are and how bad they really are, but there are absolutely consequences. And it all comes from the fact that when I create my own internal fork, I'm diverging from the rest of the community, which means that I cannot benefit from everything that the community brings in terms of updates, support, and fixes. It also has consequences, of course, for compliance and so on. I might have an S-bomb that says that I'm using a very particular version of a package, but in reality I might be using my own internal fork that is not at all anything like what actually says in the S-bomb. And that is what we are going to discuss here today. So, internal forks, why do they happen in the first place? To be honest, I mean, based on what we can see out there, I think in many cases it's not necessarily intentional from the beginning. An internal fork is something that just happens. You have a package, and for various reasons, integration efforts and so on, you feel the need to modify something, and it can start out as your own small patch, but over time it grows. If you at some point were to upstream this and realign with the upstream version again, then we wouldn't be talking about an internal fork at all. So here I'm specifically talking about the scenario where you continue to maintain this as your own local version of a package. In some cases, and I think this is one of the things that could apply to the financial industry in particular, it might be the case that company policies prevents me as a developer from upstreaming my changes. And that is the reason why I feel a need, or I'm effectively forced to maintain my own local fork of something. That can absolutely happen, and that is of course something that needs to be changed at policy level when that is the case. It could also be sort of practical or organizational reasons that I might have a team that leaves behind a modified version of something, and for various reasons I'm not able to pick it up in remaining organization. So an internal fork is basically a sort of an orphan piece of software that over time the team might forget about, but of course the liability or the liabilities remains. One thing that we look at when we do audit is that we collect a little bit of statistics at aggregated level. I mean, what do we see among software projects? And now we're talking about not only open source projects, but commercial software projects out there. And in particular, in this context, it's interesting to see, I mean, what's the willingness among people to actually modify code and keep it local themselves. And there are different ways you can measure this. If we detect that we have a file that has been modified, there's always a matter of definitions. Is this an upstream file that someone has modified, or is it actually the reverse, that someone has created their own file and then they have injected a bit of a snippet of code from some open source projects? So just in order to sort of collect or aggregate some data, we have put a little bit of a threshold that's 60%. If 60% of the file matches something that we can find upstream, then we say that, yeah, this is probably someone has taken an upstream file and modified it. And actually, in some recent projects, we've seen that in the order of 2 to 4% of the files have been modified in some way. 2 to 4%, I mean, it might sound like a small or a large number, depending on where you're coming from, but in a large project, this becomes substantial. It's a substantial maintenance burden we are talking about. A little bit of my own speculation here is that I think one thing that could be fueling this, the willingness to modify software and keep your own local forks, are actually AI. I think it's the case that if we look back, in the past there were some natural barriers against modifying source code, at least unless absolutely needed. And if I were to take an open source component, usually a fairly large code base, and modify it myself, I would have to spend substantial amount of time to just get to know the code base, to understand the code. Otherwise, I cannot make any modifications or achieve what I want. Now, AI has kind of changed that a little bit, because many developers today, I mean, they're happy to take on unknown code bases and ask Copilot or Codex or any agent to make modifications on their behalf. Which on one hand means that I don't have to understand my code base before making, or at least I don't think I need to understand my code base for making modifications, and making modifications has become really, really cheap. Which means that this, to create my own fork of something, I mean, it might be seen as an alternative, and it might be seen as cheap until I'm hit by the maintenance burden, and all of a sudden it's not cheap anymore. So AI might be at least contributing to the problem here. And what is the problem? Why does an internal fork hurt? Well, I mentioned a bit of it. There are many different ways an internal fork adds to the maintenance burden and will causing me a bit of headache long term. For one thing, it's of course about normal maintenance. An internal fork creates a maintenance overhead for me. So everything in terms of upgrades, adding my own patches, porting my own patches is something that I will have to do over time. Unlike when I use an upstream version and I'm aligned with the upstream version, I cannot no longer benefit from all the work that is carried out in the open source community. And everything else is upon me. So I need to retest and redeploy and ensure that all the changes that I do locally, that they are actually okay. It also means that whenever I have an issue, it might be a security issue or I have a patch from the upstream community, it's not obvious that I can apply it as is. It might be incompatible with the changes that I've done locally. It might also be the case that I should really do some retesting of the entire component if I were to combine my own patches with new patches coming from the upstream. And the end result of all this is that there's a higher risk that these internal forks go unpatched, unmaintained, and not updated, simply because I'm not prepared to do and take that maintenance overhead. In the end, that means that if I were to sort of put a price tag on this, the risk associated with security here might actually be higher than the actual maintenance cost. Because when I'm hit by a potential security problem, the risk might be almost uncapped. And that brings us into, okay, can we put numbers on this? This is a financial event, so of course we should talk in terms of dollars. Well, I would make a difference here between, I think there could be two kinds of internal forks. The ones that I know about, that I'm aware about, and the ones that I didn't even know existed. And both of them, unfortunately, exist out there. The ones that I'm aware about, well, for them, it's pretty straightforward. I can basically make an OpEx model. I mean, what will it cost for me to maintain this long term? Because I know what projects I've taken on. I know what modifications I've taken on my side, and I can more or less budget for that. The unknown forks that I don't even know existed, that's a bigger problem. Because in this case, I mean, that can be an almost unlimited security risk, which is unbounded, more or less, if I wanted to put a price tag on it. The first kind, that's more of a technical debt that slowly builds up over time. So, in short, yes, it's possible to put a price tag on it, but in many cases, that price tag, if you look at the worst case scenario, will be almost uncapped. Okay. So, if I realize that this is a problem, if I realize that I might actually suffer from this problem, I mean, I might have forks in my code base that I'm not even aware about, what should I do without it? Should do with it? So, the first step is, of course, to try to assess and understand the situation, to find and identify what kind of forks I have in my code base. And this is not anything that is easy to do by just looking at the code manually. I know that I'm a bit biased here, I mean, being tools vendor, but I do believe that in order to do this efficiently, I mean, you do need proper tools. One problem here is that if you look at how our industry has worked. I mean, traditional SAA tools sometimes fails when it comes to your internal forks. And it's simply because of the technology that they are based on. In many cases, traditional SAA tools as well as package managers, I mean, they basically rely on manifests associated with different software components. Worst case, they might be missing completely in my internal fork. In some cases, they might exist there but be incorrect because they don't correctly reflect the fact that I have made modifications to my component. So the end result being that internal forks go undetected. If I have a tool that only relies on working at the package manager level, looking at manifest files, I will simply not detect it in the first place at all. Also, if I try to do this at full file checksums, that's another method I've seen out there. People try to identify software based on checksums. I mean, the problem is that the moment I make even the first slightest change, of course the checksum will change, and yeah, I can best case see that there's been a modification. I cannot properly track what has actually been modified. So in order to get this to work in practice, I think what's needed is to have solutions that are based on source code analysis, but at snippet and subfile level. And this is something where we have done a lot of work, both in terms of implementing tools and also to see how they can be used in scenarios like this. Because if you do an analysis at snippet level, then you can actually find all possible injections, both of third-party software as well as modifications that could have been made to this software. Once I found them, once I have identified the potential forks I have to handle with, then of course it becomes a practical problem how to tackle this. And usually I would recommend start to look at security impact first, because at the end of the day, if we try to put a price tag on this, security impact is what's almost uncapped. And then of course look at other components beyond security critical issues in level of decreasing business importance. And at the end of the day, the only way to tackle the problem here is to start to first maintain, but then preferably, if possible, upstream and contribute back the internal forks that we have, which means that we need to assign proper owners and start to track status here as part of governance for these different software components. One area that I think deserves a little bit of special attention is the topic of vulnerabilities in internal forks. And in this case, we have a little bit of a special problem to tackle, because the way that we track vulnerabilities today within the industry is, of course, that we are using CPEs and CVEs. CVEs constitutes our enumeration of the vulnerabilities themselves, and CPEs is basically the enumeration that we have for the software components, which means that the CPE becomes effectively our means for mapping a component towards a vulnerability, or the reverse. Now, the problem is that if I have a software component that I have forked and modified myself, CPEs are assigned. There's some sort of official registry of assigned CPEs, and my modified component is probably not correctly reflected in any of these CPEs, which means that either I have none for my own internal fork, or I, perhaps even worse, have an incorrect CPE, a CPE that doesn't correctly reflect what I have in my code base. Which means that if I scan this at the CPE level, looking at what kind of CVs are associated with the CPE, I will not detect anything, or I will not detect the truth behind it. Again, going back to what I said in a previous slide here, I think the only way to tackle this is to do this at snippet level. So what we have done is that at FossID we have done like this. During the last 5 years, basically, we have gone through all CVs that have public patches. The moment you have a public patch for CV, that means that we basically have knowledge of what are the exact code lines that are affected by these CVs. And we have annotated and curated and collected this in a database, which means that we can scan source code and not look for the presence of CPEs or look at specific component names and versions. We can look for the actual lines of code that constitute the vulnerability, which means that regardless if we have created an internal fork, regardless if we have renamed it, regardless if we are not tracking version numbers or CPEs correctly, if the vulnerability is there, it's still possible to detect it. And of course, if I have internal forks, and most people do, this is actually needed. I mean, if the end result here is compliance. Because at the end of the day, if I create the bill of material for my piece of software, the bill of material doesn't really reflect, well, it only reflects what I claim that I ship. It doesn't reflect, in most cases, how much I changed it. And this is sort of the core of the problem. If I have made changes to my component, that means that the CPE as being the link towards vulnerabilities that has been broken, and it's not really relevant anymore. And which means that whatever I bring towards auditors, regulators, it's not a correct and true picture of the software that I actually have. And again, if I really want to make sure that what I have in the SBOM really reflects reality, the only way to do that is to verify. Verify by actually comparing with the source code. To sum up, I think internal forks are common. It's very common based on the numbers we have seen. There are not in every project, but more or less. They are everywhere. If I know about them, at least they are predictable and manageable. I can handle them, I can budget for them, and I know what needs to be done. It's just a matter about doing it. If I don't know about them, I have internal forks that I was not even aware of, I will effectively not handle them properly. This will become a security risk. And in any case, regardless whether they are known or unknown, over time they accumulate as a maintenance overhead and a deferred maintenance cost. I think that AI, generative AI, recently has contributed to making the problem slightly worse because, as I said, it has opened up for people to modify codes that they wouldn't have modified otherwise without that kind of help. But at the end of the day, as I touched a little bit on here, there are means to work around the problem, so to say. To, for example, detect vulnerabilities even in the event that this is something that I modified completely myself. And as new member here in FINOS, we are of course happy to contribute any way we can and offer our help and tools to FINOS-led projects. So just reach out if you have an ongoing project under the FINOS umbrella. That was it. And I think I was slightly faster than I expected, which means that we have probably time for questions. Please.
So when would you be supportive of internal forks? I can sit here and invent a hypothetical organization of 100K people, 50,000 circles, and I run, say, the most basic Java applications. Over 50 million in support costs if you go by the vendor's price. Like, you know, those are big costs. It's when do you, and a lot of what you've said would be exactly what I've seen when you've got lots of different people forking for one project. as opposed to some sort of coordinated effort either internally over a big organization or between organizations, which isn't internal, of course.
Yeah. No, and I mean, if you listen to, I mean, pure open source advocates, I mean, they would say that you should never create, you should always upstream and contribute back to the community. But in reality, I mean, sure, there are situations where it's sort of simply not possible to upstream. And yeah, so I mean, I can think of two situations where I realize and must acknowledge that it's sort of completely impossible to upstream. And one is, of course, in the case where I have made changes or adaptations that are kind of secret. I mean, this is not anything I want to show to the community at large. Of course, then I'm simply not able to do it, and I need to, face the cost and consequences of that. The other one, which I touched upon in one of the slides here, is, of course, if I might be working in a large organization where you have policies that you are not allowed to contribute back to open source. And I think this might be the case in the financial industry to some degree today. I think it was the case in, perhaps to a even higher degree within the telecom industry some 10 years back. In that case, driven by the fact that these telecom companies, I mean, they had an IP portfolio, I mean, that constituted significant value. I mean, they licensed patents around this technology, and they were afraid that if we start to contribute back to the open source, then that could leak. So there are a few cases, but in general, of course, whenever I can, it's better to work with the community than against it.
What about when the owners don't want me to? And that's what we're seeing now.
Yeah.
And obviously that can lead to external forking.
Yeah.
I mean, I guess we go all the way back to Jenkins and Hudson. There's a number of examples.
Yeah. No, and I mean, let's face it. I mean, that is the way several, I mean, well-known open source components have been created today. I mean, they came out as a fork of something. And at the end of the day, I mean, if the maintainer and owner doesn't accept your patches, of course, that's your only remedy at that point. I mean, to say that, even though in that case, I mean, it might be better to create a public fork of it, so to say, so that at least it might be the case that you get the help from other companies, other people to maintain it over time.
Thank you.
Yes, more questions? No? If not, if you think of anything more, please catch me on the floor downstairs, and thank you for listening.